Alright, so sort of the last topic that you're responsible for covering in this section of the course, in our trigonometry treatment here, is what happens if I have to solve a problem that involves more than one triangle at the same time. So we have to use sine and cosine law together with multiple triangles. So let's really mix and match here. So first of all, we're going to talk about strategies for this. So we're going to diagnose a problem, to determine an appropriate solving strategy, and then we're going to apply the sine and cosine laws in multiple steps to find a good solution. Okay, so here's a specific example that we'll use to sort of show you how we figure out a strategy, and then after that, sort of what we do to carry that plan out. So first thing we're going to do is look at this triangle that we have, and it says here that we want to find the measure of angle theta, which is up here. So I've listed some strategic questions that I can sort of ask myself so I can develop a plan for figuring out what theta is, because you can see this is quite a complicated diagram with lots of things going on. So first of all, it says, in which triangle do we find theta? So it's obviously then this triangle up here with these three sides that I'm just sort of putting a little mark on. So in this triangle up here, I see that I've got theta. And it says, is there enough information already? So we already know where we're looking for theta, but is there enough information there? So if I just had that one triangle to go on, would I be able to figure out theta? Well, there's only 2 bits of information there. That doesn't seem like enough. So I guess an answer to that would be no, because even with sine law or cosine law, I need at least 3 other things when you look at the formulas that I have. So there's no law that's going to get me any of that information quickly, and I can't really figure out like an extra angle or something with my 180 degrees here, because I only know one angle. So what more would be needed? Well, let's take a look at this triangle up here a little more closely and see what we would need to help us get theta. And one thing that you'll notice, and it's a good thing to look for at all times, is opposite pairs, because remember sine law there. So if we look at the 80-degree angle and the 25-unit long side over there, that's a pair of opposites. If I wanted to get theta, all I would need to have for additional information would be the length of this side over here. So let's call that side x. So if I knew side x, I'd be in business. So what more is needed? Well, the other thing I need here is side x. Okay. So if I want to get that, can the other triangle help? Well, let's have a look. So the second problem I'm trying to solve now, so I can get back to do my first problem, is how do I get this side x in the other triangle? Well, what things do I have? I have this side, and I have this angle down here. So what I notice is that I have side, angle, side. So I know that I have a side, another one, and the included angle, and I want to get the missing side. That looks a lot like cosine law. So the answer is yes. So we're going to have to work backwards through all that to get our way back to theta. So what's our strategic plan? Well, the first thing we're going to do is we're going to use cosine law to get side x. So that's one way to go. And after we have side x, then we can use the sine law. We're going to use sine law to determine theta. So this problem with the 2 triangles becomes a 2-step problem. So let's actually carry that out now. Let's do the 2-step and see if we can figure out what that angle is. So the first thing on our strategic plan, remember, was we want to use the cosine law to get side x. So let's go for that. So this was our side x. So if we're going to do that, I guess we'd have to think of this as being like a c and a little c here. And then we could say that this could be like your side A, and this could be like your side B, and then you would have like an angle A over here somewhere and an angle B over here. But as long as we have our C's and our A and B, we're okay there. So we're going to say that C squared equals A squared plus B squared minus 2AB cosine of angle C. And this is finding x, first of all. So we called that side x. Let's get that first. So filling in the details, we have x squared equals 23 squared plus 21 squared minus 2 times 23 times, that doesn't look much like a 2, I better fix that a little bit, times 21 times the cosine of 60 degrees. Okay, so we figure out what x squared is first, and then we take the square root. So let's see what we have there. 23 squared plus 21 squared minus 2 times 23 times 21 cosine 60 gives us 487 for x squared. And that's going to tell me that x should be equal to the square root of that. So the square root of 487 is 22.1 roughly. So we got about 22.1 units for x, and that makes sense. If we got 60 and 23, that's a pretty reasonable length. So x is going to be 22.1. All right, so here I have x equals 22.1 units. And now that I know that one, remember, the next thing we had to do was find theta. And to find theta, we said we were going to use the sine law. So we've got opposites and opposites. So we're going to say that sine theta over its opposite side, which is the 22.1, is going to be equal to sine of 80 degrees divided by 25. So then sine theta is going to be equal to 22.1 times sine of 80 divided by 25. So then we have sine theta equals 22.1 sine of 80, and then that's divided by 25, and that gives us 0.8706. So we have 0.8706. Oh, looks like I missed a zero there. That's 80 degrees. So then theta is the inverse sine of that. So inverse sine of that stuff we just came up with is 60.5 degrees roughly. So we just figured out that theta is about 60.5 degrees. Not bad. So a two-step process. So here's your thing. Ask yourself good questions to make the logical connections that you need. What do I have? Do I have enough in that triangle? What might help? Then we developed a plan using the other triangle to get it, and then we carried out the plan.